Hey everyone! Today is Friday, my face-to-face Fridays, and today I'm on a topic that, my goodness, is something that I talk about constantly, which are the words of science. I even have a slideshow. I was going to really make this into a video, one of my videos for Dissident Science, which are my edited videos with script and all that. Boy, those things take forever to do. I get really good retention, meaning when I do those scripted videos for my subjects, I get people who really watch those pretty much all the way through, and that's a great asset for making them, but they also take a long time to make. And I've been busy, of course. Hey, I'm sporting my new t-shirt you can see here for our book coming up, and our model, Principia Mathematica 2. And right on here it tells you pretty much our whole model. Okay, gravitic, which of course that's been around a while. That word I found out. Electric, of course, has been. Magnetic as well. But luminic, I think, may be one that I actually made up. That's, of course, with my father, who came up with a solution to the wave-particle duality. But regardless, we're working on that book and hope to have it come out. And we have our t-shirts here. And we plan to be buying about 30 of those books and then selling them. But I'm not here to sell my book or talk about it tonight, but I am sporting that. And of course, I got my physics police hat on there. And next week, for those who don't know, I think no one knows actually, I will be having a special guest live, same time, 9 o'clock Eastern time, 6 p.m. on the West Coast, and that's going to be Jeff Yee, who is offering $15,000. He's a dissident science to help use the program called Blender, which is an open source graphics physics kind of engine, which allows you to do modeling of the real world using Newtonian physics. And his model, like our model, is completely Newtonian, and he's looking to get people to help him out with that, and he's got funding to do that, so that's pretty cool. So I'm going to be having him on next week, so you want to make sure. I don't want to put it out there because I think I put this on Facebook, and Facebook only announces 7 days ahead of time. So as soon as this is done, I'll be announcing, and you'll see the announcements for our my next live event, which will be a week from today with Jeff Yee. Check it out. Energy Wave. I think I may have that. Let me check if I have this here. There it is. I'll put this up there. EnergyWaveTheory.com. Go there and check it out. You can read all about his program, that his project that he's working on. It is quite amazing. So again, I want to thank all my subscribers. We continue to grow. I'm over 3,250 subscribers, gaining subscribers every week, every day. And I want to welcome all the new subscribers. I usually make my videos. Takes a little time to put them together, to write them out, record them. I'll tell you, me reading scripts and recording them, oh my goodness, it's not easy for me. It sometimes takes me 3 hours to do that. But I do have a script already, and it's on Ether. And those of people who subscribe to Ether, they may not like it, but I will tell you, it's going to be quite interesting. Because unfortunately, those people who are etherists don't know the problems with ether, and they don't seem to care, and that's not good. And we need to make sure two things that that video is going to be talking about is, one, there are alternatives to ether. It's not the only way you can get waves for describing light. And two, there's quite a number of very basic problems that no one in most modern theories really address. So I'll be putting that together. Tonight I am broadcasting live to the Chappelle YouTube channel, which we're closing in a thousand. When we first started our campaign of doing more and more on social media and YouTube, we only had 100 some subscribers, but we're up to, I think, 715. I got a live count here on one of these apps, 714 there. It's good to see. So I try to get people to, get people from the CNPS over to my channel who don't know about it, and then people from my channel, which has over 3,000 subscribers, to get to know the CMPS. So I thank people for jumping in from my Dissident Science channel. I'm also broadcasting live to my Facebook page for those people who wonder what the heck I do. So I know people come in and out, and I really do appreciate everyone's support, and I do recommend also that you subscribe to some of these other channels that are out there. And if you want to know some of the channels that I think are worthwhile, you can see those channels actually listed at Scienceworkorg, which is our website for critical thinkers. So those people who are new to the idea that, in fact, mainstream science isn't exactly what we think it should be, and there are people actually working outside the mainstream. So that's a website you can go to. You can find out the problems that there are in science. There's a problem section. You just click on it, and then you get articles in each of those areas. You'll find some of the scientists, the best scientists today, working outside the mainstream there, and people's who have their own theories, their new theories. And so if you're from the electric universe, Walt Thornhill is there, for instance. If you follow any of the other models, they're there. Jeff Yee's there. We are there. I want to say hello, Farouk. How are you, Farouk? He is from Morocco. It's really late there. My goodness, Farouk. Go back to, what time is it there? It's it's like 2 in the morning, I believe. I plan to try to get some of my broadcast live to be at a time frame where Europe can get in there. Right now I'm just doing it on Fridays. The prime time really is a Saturday morning from 10 a.m. to 12 noon. That's a prime time that really works well for around the world. You can get almost everybody in from Australia. The night times where most people are sleeping is across the Pacific at that time. So I'm really thinking about trying to do it on Sundays from 10 a.m. to noon. So let me know if people are maybe interested in that, especially those people in Europe. But Farouk is there at 2 in the morning. I know you may go to sleep, but if you do, this is recorded, absolutely recorded on numerous channels. So this will be available on, of course, Dissident Science. It's there live. In fact, if you're watching it now, you can always pull back. But anyways, Farouk says, I am not working tomorrow. But again, greatly appreciate people's patronage. And, I'm here to interact with you. And just for those people who don't know, you can actually join me live on the air. That's what's really great. This is a StreamYard, it's called. And you can join me by going to greenroom.dissidentscience.com. That'll get you to the place, the link that you need to get to in order for me to put you on the air. Don't worry, you can jump on the air if you don't have video or don't want to be a video, or even reveal your name. I know some people don't like being revealed who they are because of their dissident tendencies in a world that doesn't really support them. So you're very welcome to join me. I call it the Green Room. So go to greenroom.dissidentscience.com. No www. Green Room is in place of www, and put that in a browser, and you can go directly, and then we'll be able to talk on air. So again, welcome everybody from John Chappell channel, the John Chappell Natural Philosophy Society. I try to again do some cross communication between those. And if you haven't checked it out, go to, let's see, I think I have that here. Here we go. You can actually check out our Wikipedia. We're going to be redoing our website soon. I've been promising that, but you can go to our Wiki at wiki.naturalphilosophy.org. That Wiki is actually it's the same as Wikipedia, but it is a closed Wiki because otherwise people go in there and trash us, because people who are in the mainstream, they of course own the truth as they think. So if you're interested, we have over 10,000 pages of information there. Very interesting. So you want to check that out. And I do have some people already making some comments. I will look at some of these, try to keep up with those. David Hilster, could we put this science as a guest author? Oh, that's, I don't know. That's funny. Can we put this on our, I don't, oh, that was that's funny, because the software here put a message from myself to somebody who talked about putting a paper that was very interesting. So, all right, I see people do some comments there. Anything that I see that's interesting? What is inside of light? Magnetism, electricity, double force. So what are their strengths? Well, let's just take a look at some of these. Oh, they've got some better, little different graphics. I think you can fit a lot more there. They make them a little bit more sophisticated each time, because it is this program StreamYard comes directly over the internet, so the updates happen automatically. So Mitch is saying, what is inside of light? Well, it all just depends on what you subscribe to is what light is. In our particle model, we have a model of light. People who have ether models have their model of light, which is waves through ether. People who have lattice models, I don't know really anybody working really a lot on a lattice model now, but just imagine that the universe is a lattice, sort of like, and that lattice is vibrating, or waves can be sort of going through that, sort of like imagine a scaffolding or something. But so what is inside of light? Again, depends on what you subscribe to, what model you have. And my wife, oh my gosh, my dad and I have our own model. He came up with a model of light. It's right here, the luminic, which is basically just waves of particles coming at you. So it's not one particle, but waves of them. And again, what's inside that? I'm not sure really what that would mean. Not in our model. There's really nothing inside it. Light, at least at our level, it's just a bunch of particles coming at you, like bombers coming at you, flying at you. They go the speed of light. They're like photons, but photons supposedly would cover. Photons were not described in the same way my father described them. So, magnetism, electricity. Again, depends on your model. Right here we have all of those. For our model, at least, gravitic, electric to us is just simply particles going in the same direction. In fact, we claim that they're all the same particle at our level. But again, that's one model. I'm not here to tell you that's right or wrong. So double force, so that they, what are their strengths? Again, all these questions people have, all the comments, all the words people use, in fact, are usually the biggest problem is we talk about words and have no idea what the physicality of any of those things are. So let's see what another comment. I think there is an immaterial side of physics like ether's nature. Well, I myself and many people, and especially the people who are making, I would consider to be the people today. In fact, in my talk today, you can see here, I'll make it a little bit bigger, but I have slides prepared today. And those slides, I'm going to talk about an article that I came across that was pretty interesting. And I'm going to talk about the language they use in it. It's really, really interesting. This is what I do all the time. Just to give you an example, today I worked probably 3 or 4 hours on writing a computer program using a computer programming language my friend and I came up with 20 years ago for computers to write programs to understand human language. So I spend lots of my time trying to get computers to understand language. So I think about what words mean a lot. And today and age, what we have are people who have models who are opting to be, most of them, completely physical. Most of them, I'm not sure. The only two that I see doing that truly, in my opinion, are Borkert, Glenn Borkert's infinite universe theory. You can look up Glenn Borkert. And our model, which is based on infinity and Borkert's concept of infinity, we have everything as a physical entity. There's no force in the universe that doesn't have a physicality to it. whereas other models will have fields. For instance, the electric universe talks about electricity and Birkeland currents, and the universe is mostly electric, or all electric, they claim, yet they do not really have a model for what an electric field is, or maybe even a magnetic field, any of those things. So that's one of the things I would say to you. The question again, the comment is, I think there is an immaterial side of physics. Today's new models out there, and people who are doing new models will vehemently disagree with that. There is nothing in the universe that is immaterial. I don't even know what that means. And this is what we're going to talk about, the words of science today. So let me see if there's some more comments before we get going. Tesla's unseen energies. Well, if again, they're not unseen if you have a model to model everything in the universe. So if you have a model for everything, there's nothing unseen, and you can describe what Tesla was trying to do and whether it would work or not. And our model will give some answers to that, but that's just one model. Einstein says space was immaterial in the 1920s. That's nice, but of course space-time is tensor equations. There's no physicality to that at all. Although a friend of mine I work in a supercomputing research group at my company, and one of the guys there said, no, tensor equations are physical, and I'm sorry, I don't buy that at all. And again, I am telling you, from those of us who are working outside the mainstream for whether it's 5 years, 10 years, 20 years, 30 years, the pretty much the consensus of those working on models today is it's all physical. There's no magic. People are tired of sort of the magical side of things, and that's what we're going to talk about in the particles are not fields and fields are not particles. Well, again, we're using words, and I want to know to Scott, what is a particle? What model are you using? And if you're saying it doesn't matter, then I will say to you, well, what can you say? Because to me, if you ask the average person on the street, you can tell people energy and fields and even particles. But if you don't give them any notion of what's really going on, that it's invisible things. There are people who that they believe in non-physicality, and I don't buy it. I don't like it. I don't think we get anywhere with it. So the electric force in dark mode. Okay, I think people are talking about Tesla. Again, we're using lots of words, and that's very interesting. So hey Dryas, good to see you. Let's see. What about the abuse of the word field? Oh, Bubble Puppy, I will tell you, that's one of the things I've been literally saying for over 10 years. If you ask anybody who knows me and who've been to the conferences, our CNPS, NPA, and CNPS conferences, those have been the last 5 years. I've been going to conferences since 1996. Whoa, that's almost 25 years now, I guess. I've been going to conferences with dissident thinkers. I've asked that question over and over. I didn't have any answers for it, but our model, we have an answer for those things. So the answer is, what model do you subscribe to, and please give me a definition of it. And if people ask me, I will give it to you in our definition for the particle model, right or wrong. So, and yes, I will continue to ask that question to everybody in the electric universe, because it's wonderful to say the universe is electric, but if you're saying that without knowing what light is physically, without knowing what gravity is physically, and not knowing what electric field or even charges, I say that's nice. It's a lot of words. It's a lot of interesting ideas, but sapphire is only running about at 7% when heating affected happen. Oh, wait a minute. I think this is here. It's the one before. Sapphire is a wonderful experiment that's being done by the people in the electric universe. I applaud them. I applaud the electric universe, because I support all and anybody working outside the mainstream. to say that my theory and my father's theory is right over someone else's. That's not ours to judge. As Alexander Unsker says, he says, everyone should work on what they think is true, and the world and the society should be able to choose to think and look at what they think is right. And if something is working real well, that's going to automatically be picked up by people. And once a generation of the scientists in the mainstream die out, the new models will take hold. So I applaud the Electric Universe people constantly. I will support them to the end. Work on that as much as you can. I can still ask my questions, but I think anybody who thinks outside the box, who does not accept things that were taught in school just because people say it's true and then you think about it, doesn't make sense or it's illogical, that kind of thinking is really, I think, really important. Let's see, I believe math like gamma and E equals mc squared in geometry for understanding physicality. I'm not sure what that means. Again, a lot of words there. Equals mc squared. Energy, of course, is a concept. Not sure. So I won't be able to always answer all these questions or may even get comments. Not even the mainstream knows what light is and gravity and magnetism. If we knew, they would win a Nobel Prize. You'll be surprised. Our model has a model for all that. And we're not worried about Nobel Prizes because Nobel Prize, in my opinion, is not worth almost anything anymore, especially in physics and cosmology. It's all a popularity contest, and it's people inventing things, pretending to find them, and then giving themselves awards for things that never change humanity in the least. And they always say that it's always earth-shattering, and the whole universe depends on it. Let's see, or even what makes a charge. They are just saying intrinsic property. Absolutely, aka Debbie. That is one of the problems, is people talk about charge. I have had this argument since I started my YouTube channel, and I even went on that one guy's channel, which I'll never go on again, but I did, and we got in a knockdown, drag out argument about charge. Charge is not a real property. It is something that we came up with. So anyways, let me go on. I've addressed a lot of the issues here. Let me go ahead and get on to my little talk here. I made some slides for this talk. It really does get my dander up. So let me put those slides up here and start going. Take this off the screen, give myself some space here. Alrighty, and let's go to it. So the words of science are terrible recklessness with scientific terminology. I will tell you, this is my biggest pet peeve right now in science. It used to be the field, but now we have enough people working on what a field really is that I don't need to hound on that anymore. Our own model, my father and I's own model, the particle model, will tell you exactly physically what everything is. So we know now that people are working on that, even including myself. So I'm very not too worried about that's not such a big thing with me, but I will tell you the words. And I'm going to show you an article that really points this out. I think it's an excellent article. So let's take a look at it. Let's see here. Oh, wow. This is not... sorry, it's supposed to be changing. Oh, here we go. There we go. Got too many screens on here. But here's the title that really caught my eye. Lasers made of space-time wave packets are breaking the normal rules of light. And I'll tell you right up front, this is an extremely interesting experiment. And this is, I really like this article. It was posted on Facebook by a friend of mine, of my father and I. His name is Chris Ekman. He's a young guy. He worked at the Stanford Linear Accelerator, but he is a dissident thinker. He got his start with Brown's gas. Sometime I'm going to see if I can invite him on. an amazing young man. I hope he watches. I'll send this because, touting his, he is really amazing because he's open. He opens his ears to different ideas. In fact, he was in my film EinsteinWrong.com, the documentary. You can check that out. Go to EinsteinWrong.com, watch that online. He was in that film in this one of my father's lectures at his house at the time. But he put this on Facebook, and this caught my eye. And in fact, the behavior that they're finding has to be explainable. And my father and I's model has to be able to explain this too, because your model of the universe must explain what is observed. And we're going to take a look at this. So again, I'm not sure. This is on Vice.com. You can look this up on Vice.com. Just put in lasers made of space-time. Just put in space-time wave packets, and laser you'll get it. So it turns out the subtitle here is "Turns out pretty much everything we know in optics is out of the window." Well, you can tell this is a non-native speakers do write quite a lot of English today. I do notice that. I don't care. I'm not worried about people's good or English or bad. And I won't read this because the English is a little funny. But I think these guys are foreigners, are not native speakers of English. So that turns out pretty much everything we know in optics is out the window, or they say out of the window. And optics, of course, what I liked about that part of it was these are experimentalists, so you don't hear too much of the jargon. But unfortunately, you hear this, you see that they have in quotes space-time wave packets, and that's where the language in science comes in, and that's what we're going to take a look at. So let's read some of this article. I put left the title up there for you. So read it. One of the most basic properties of light is that it changes speed and direction in different substances, such as water or air. This process, known as refraction, explains why glass prism splits light into many colors, which is actually called dispersion, and why a pool may appear shallower than it really is when viewed from a deck or diving board, which is true. So what they call the speed and direction changes. Now, of course, this is what they say. In our model, we say that actually the speed of light doesn't change. It's just taking a very long path. In fact, it's not a straight path. And so that's a different explanation for it, but this is what mainstream science says. And of course, the reason they say that is because they don't have any model of what light is. So they're just saying that it propagates and it changes speed. So again, these are the way I look at articles today. Let's go to the second paragraph. Second paragraph. Now, scientists have managed to defy this photonic principle with a special laser made of space-time wave packets that do not slow down in denser materials, according to a recent study published in Nature Photonics. Study of photonics is an area of studying light. They call themselves experts in light photonics. And I actually do know one and interviewed one for my movie, even though he wasn't in it. I told the story many times about how he says we have no idea what a photon is or what a light is. And he's a guy who's been studying light for a living at a university for 35 years. That's the truth. But of course, if you ask the science evangelists, they're all going to say, of course we know what a light is. It's a strange thing. It's a wave. It's a particle. It's both. And you can't separate that, et cetera, et cetera. So it says, in fact, the new class of lasers can accelerate in a dense medium among its other optical superpowers. Now, I don't know if that's accelerate means it goes faster than the speed of light, or it means faster than it should be in that medium, which is always slower than the speed of light in a vacuum. Okay, let's go to the next page. Scientists led by, I won't pronounce the name, Eamon, I'll just call him, a professor of optics and photonics at the University of Central Florida, oh my gosh, in the state where I'm living now, created these bizarre laser beams by linking their optical properties in both space and time. Now, the reason okay, I'll read the rest of the sentence, a tactic that unveiled unexpected phenomena according to the study. So let's take a look, start looking at the words they're using. Bizarre. And bizarre is and the word space and time. Now, of course, laser beams, which are high tech, But the word bizarre in space and time, I want people to sort of take note of. When people are writing articles, they want to be sensational, they want things to spark interest, and all of a sudden you hear about space and time. That, of course, conjures up general relativity and Einstein's relativity, space-time, and that was not, how do you say, accidental, even though in reality they're talking about space and time. They are using this language, and that's what I'm going to talk about for this article fact. So, and the bizarre, of course, is just to make people an unexpected phenomenon. So, oh, the mystery is here in the article. So this is how do you say, marketing and writing interesting prose. What happens when you go into a laser beam and manipulate the space and time aspects and correlate them with each other, connect them with each other? So now we're starting to see, all right, we're using space and time again. Now that's going to hit upon people's, how do you say, radar and search engines a lot more if you conclude those in your text. And people aren't stupid now, because we know that texts are in fact indexed automatically by these huge systems. And when you see the word space and time, or even space and time, you're going to get more attention. Just like if you throw Einstein into your article, people are going to read it more. So anyways, again, they're talking about the manipulate space and time. It's not calling it space-time. You got to be very careful here. And you're going to see how people's language morphs into something so that they can get attention. So that their little experiment goes from no one caring to being in and picked up by lots of places, including Vice, of course, here. Turns out pretty much everything we know about optics is out the window. Now that's pretty cool. I like that. You might be scratching your head over what constitutes the spatial and temporal aspects of a laser beam in the first place, and why they are normally kept separated. So far, they are talking about stuff that isn't the mumbo-jumbo of space-time. All right, let's keep going. A laser's spatial properties typically refer to the beam's appearance in space, such as its shape and size and shape. So again, the laser's spatial properties typically refer to, oops, sorry, got to go backwards. There we go. Sorry, I've got it wrong here. There we go. No. It's not wanting to do that. Let me get out of it and start again. We were here. Okay. Okay. Sorry about that, folks. I'm trying to do this live, and these things happen. These happen. So again, the laser spatial properties typically refer to a beam's appearance in space, such as its shape and size and shape. Its temporal properties relates to the values such as the duration of its pulses, which are often incredibly fast bursts measured in the nanoseconds. 1 nanosecond equals 1/1000th of a second. All of this is real. This is real physics, real things. It's about space, which is one thing, the space between the pulses, and the time between those pulses. So far, we're in the real Newtonian physical world, I believe. Everything's Newtonian. So this is all cool. I have no problem with this. All laser beams produce light in which those two aspects are independent of each other. That's cool. Explained Aberrati. Let's call them Aberrati. Sometimes they do get coupled, but it is considered a nuisance that messes up the beams, so you try to avoid it. Okay, so they get coupled. What's he coupling? Well, we're going to find out. Our work in general on this topic that we've called space-time wave packets is to look at the consequences of intelligence and purposely going into the optical pulse and connecting the spatial aspect with the temporal aspect. So here's where it goes awry. This is where this whole thing is a sellout. This is where the authors purposely are using bad language because they'd rather do that and try to get noticed and use vocabulary that gets them gets them attention. Now, believe it or not, dissidents do the same thing. People will use, dark matter is electrical. The electric universe, people say. Why do they say that? Even though dark matter doesn't exist, that we have very good explanations of why it never existed and why that the postulation of dark matter was wrong and didn't need to be even postulated in the first place. Doesn't matter. Many dissidents will use the same terminology in hopes that people who already know the terminology that people have will say, oh, okay, I get it. So what do? There's a spatial property. There's spaces in between the bursts of beams. Like you can measure it literally. It's a measurement. And there are timing of when those things are shot out. And he's saying, well, you got to be careful. You can't mess around with that. But what we're doing is we're messing with that. So we're going to call it the space-time wave packets. Okay, so it is to look at the consequences intelligently and purposely going into the optical pulse and connecting the spatial aspect. So they're making space-time, and they know exactly what they're doing. They're using that because they know that word is loaded. It is a marketing word, and they're very aware of that. And that's, in my opinion, where they sell out. All right, so let's take a look at space-time from Wikipedia. In physics, space-time is any mathematical model which fuses the 3 dimensions of space and the 1 dimension of time into a single 4-dimension manifold. Space-time diagrams can be used to visualize relative effects, such as why observers perceive where and when events occur differently. We won't even get into the last part in the relativistic effects and the events. I'm not going to get into relativity. This has been beaten to death in the dissident community for over 30 years. Really great minds have already looked at this. Relativity is so problematic in so many ways. I'm not going to get into that. I'm just going to concentrate on the word space-time today. And they say space-time is any mathematical model. That is the key. And what's amazing is it's in physics, because physics is supposed to be something physical. Space-time, they're saying right away, is a mathematical model. Now, 3 dimensions in space, those are real. There are 3 dimensions in space. That is real. There are not 4 dimensions in space. What they are doing is the 1 dimension of time. Time is not a dimension, folks. Dimension comes from space. It's meant for the 3 dimensions. You can't add a 4th one to it. You can with words. You can do anything. One of the great things about language is that you can take words and do what you want with them. It's a free world. You can do anything you want with them. You can write a book, a literature book, where people write poetry and they can make nouns turn into verbs. Google was a noun. Now you can Google. It is now a verb. Googleplex, these things. What we take is space-time. We're going to take 3 dimensions. We're going to now say, there can be other dimensions. No, there can't. The idea is when we human beings come up with words, we look around the universe and we attach things to them. So when I look at someone called a grandma and I know that person is 2 generations before me and directly blood related, and that's a grandma. You look at the person, you figure out all the relationships, and you go, that's a grandma. We're both looking at it. We label it. Well, there are 3 dimensions out there, and these 3 dimensions are, we can call them X, Y, and Z, whatever you want to call them. And that can give us any point in the universe from wherever we are. We can describe where that is. There are dimensions. You can't just add a 4th one because there's a word. Because there are 3 of them, now I can add a 4th one. No, it would be like saying triplets, there's a 4th triplet. There isn't. That's not a triplet anymore. The thing is, in the universe, there are 3 dimensions. The moment we pretend other things are dimensions is when we go astray. And if you look at the modern dissidents today, Borkert, myself, my father, other people, many dissidents, they all will say the same thing. There are 3 dimensions. That's why we have the words. That's what we're talking about. So when you see space-time, first of all, they are right. It's a mathematical model. Yet we call it, you can see this little diagram. This is again from Wikipedia. What do they call that grid? Oh, that's the grid. That's the rubber sheet. Why they call it a rubber sheet? Because it looks like it's bending. Can we find it in space? No. That describes objects and their movements. Now, is that the physicality of it? No. It's a mathematical model. It has no relationship to what makes gravity happen. And today's model builders, even in the electric universe, they try to describe what is gravity for real. They are going to tell you there are 3 dimensions. So the idea that time is a dimension, that's the first error. It isn't. And the idea of a 4-dimensional, look, if you want to call it that and you want to put it into your computer programs, you want to put them into a spreadsheet, you want to do a calculation with matrices, whatever you want to do. And you notice they call it a 4-dimensional manifold. Again, what they're trying to do is the manifold idea is maybe I can make it into something. What is that? Space-time diagrams can be used to visualize relativistic effects. You notice, again, describe something. Newton said very clearly, my equations do not tell you what gravity is. They tell you how objects move through a gravitational field. So again, this is what space-time is. So space-time, it comes from general relativity, comes from tensor equations, all that. So let me take a look at what people are saying here. Time slows down. Well, what is time? So Mitch, you got to tell me what time is. And if you are like many of us, time is a thing that was invented by human beings to measure movement. Time is not something, and it doesn't slow down. Time is a concept completely made up by we humans to try to measure. The best, in my opinion, the best, if you want to come up with a definition, the best definition, in my opinion, one of the best, is Borger. It's real simple. Time is movement. Movement doesn't slow down. Something slows down. Time isn't like something that a clock somewhere, like a clock is in a computer chip, which goes around one tick and then goes to the next operation, goes to another tick and goes out. Some of the old programs work that way. Time doesn't slow down. So you have to have a definition of time. So anyways, again, that's my opinion. All right, let's keep going forward here in this talk. All right, we're going to go back to the article. For instance, one of the most important ways of understanding the spatial properties of lasers is to consider their configuration in terms of planar waves, which are the dependable building blocks of light. I don't really even know what to say about that. That's all mathematical terms. And the plane waves, again, what is it, a wave? Is it a particle? Are they photons? They just don't know what they're talking about. So saying they're dependable building blocks, no. They're descriptive building blocks that can't describe lots of things because they don't know. Well, there's just so many problems. So I dispute that they're dependable. They're building blocks in their terms, what they say. This is one of the parts where people pretend that the standard model for light and lasers is dependable, understandable, and it isn't. Because if a person on the street puts a gun to these people's heads and says, tell me exactly what it is. What is this? It's a physical thing. When light, I'm burning a hole through it, it's something. It isn't vapor. It isn't non-material. It's something, and they don't know. Manipulating a laser so the specific plane waves are paired with temporal aspects related to the pulse duration, such as the colors of the light, is one way to couple the 2 domains. I don't even know what the 2 domains means. Are they saying space and time? Again, now you start to see where this all falls apart. They're now trying, and this falls apart because they were totally fine talking about the space between pulses and the time between pulses. That's completely understandable. Nothing there to get mixed up. Very easy to understand. The moment they bring in space-time wave packets, they go awry. Things start to get muddy. You don't really understand any of these words because they're meaningless. They're absolutely meaningless. What's a domain? Is space and time, are they domains? Domains, what does that mean? It means nothing. And this is why, again, I've spent decades thinking about what words mean. This is where it goes awry. So what happens? You get two experimentalists doing an actual experiment that's really interesting for my father and I to try to describe, because what we want to do is find out what they're doing, exactly the pulses, the speed and the size of them, to find out what. Oh man, I just changed this. Sorry. To change, and that changes the speed at which they go through a medium. That's truly interesting because we have a model, and then our model should be able to describe that with real physicality. But the moment you start talking about domains and space-time, this is where they're paying the price to try to be sensational, and you're going to lose people. So right now, half the people who like science have read to this point, and they have no idea what they're talking about. And guess what? Neither does the mainstream. They talk about this stuff in terms of words. They claim to understand it. I have a meme at the end of this which will tell you the truth about why this happens, but this is where it falls apart. So keeping going, it says such beams cannot be produced by today's lasers. So what we do is take a generic laser beam, then we go in and engineer its internal structure to satisfy this type of requirement. You don't. You play with the spatial, the spaces in between, and the times in which you do it. It does create different colors because colors have different wavelengths. That's totally understandable. In fact, that fits exactly what our model says, my father's model of what light is. And so now they're back to something that's actually understandable. This whole paragraph talking about blocks of light and plane waves, garbage. Aberrati and his colleagues have found that very strange things occur when you start tinkering with space-time wave packets. Of course. Well, first of all, the first strange thing is you don't understand a word that you say when you start talking about those things, space-time wave packets. No one knows really what a wave packet is. Space-time, again, is a loaded word. They're not talking about that. At the end, I'm going to tell you what they need to rename this. They need to not use space-time wave packets. They're just doing that for publicity, and they get everyone lost, including themselves. They don't know what they're talking about at this point. In the new paper, they describe how these special beams take on unworldly properties when introduced to different substances. All that means is when they change the timing of the way the pulses of the laser, it acts differently. It goes through materials in a different way. There's got to be an explanation. That's the interesting part. Not the way they say it. Well, some sense. I'd throw half of these sentences away. When you go from rarefied medium like gas, like air, to a solid or more condensed medium like glass or water, light always slows down. Again, that's debatable. We don't say it slows down. It just takes a longer path, is what we say. Aberrati said, we find that we can overcome this. We can create our laser pulses in such a way they speed up in a more solid medium rather than slow down. That's what we call anomalous refraction. Now, interesting is it's not anomalous. The universe works the way it does. There's no anomalies. It's anomalous according to what they think it should be doing. And that's another word that I hate. There are no anomalies. There's unpredicted results, or unknown results, or unexpected results, but not anomalous. I am watching the comments so far. Let's see here. I'll take a look. I do want to make sure I'm paying attention to you guys here. I appreciate you being here live. That's why we're here, and that's why I like to do this. Time is not a dimension. It's a physical property of matter relative to its relation to its environment. Well, that's one opinion. Again, I think it's movement. Time, it makes nothing. is not even interesting if it doesn't. It's meant for describing movement. Clocks are there for that. Time only matters if something's moving. If everything stops, there is no time because there's no clocks, there's no movement, there's nothing to measure. So yeah, I mean, again, we're using words trying to get at it, but again, a lot of people thought about this a lot. So this is an interesting experiment. The speed of light through medium is not the same with laser pulsars that differ in spacing and timing. That's really interesting. But of course, the problem is, as the author states, our work in general on this topic that we've called space-time wave packets, is to look at the consequences. So it is an interesting experiment. That phrase is where it absolutely goes wrong. And that's why we abuse language. We abuse it for sensational purposes. Our goal is not to explain. Our goal is not to even try to understand what the universe really is. Our goal is to get our paper noticed. So we'll call something like, hey, it's space and time, it's put together. I'm sure they sat around trying to come up with this, and this is what they're going to call it. Hey, yeah, that's great. We'll put it in here. We'll get picked up. I guarantee they thought about that. That's sad. That's really sad. All right, let's keep going. Sensational descriptions. That's what they're using. Space-time wave packet term will get more publicity for the authors. Space-time term is from general relativity and is well known. Doesn't mean it's well understood. It's just well known. Again, if you want to come in and speak with me, I've got my headphones on, got my microphone. You're listening to me, obviously. And if you do want to come in and talk with me in person, you can. Just go to greenroom.dissidentscience.com. I will let you in. We can talk face-to-face, or we can just have a audio dialogue. You don't need to show your face or your name or anything, but all I ask is to be polite and want to discuss, not to preach, but would be happy to talk to anybody. So let me keep that up there. So those who may want to talk, I'm here as the person to either answer questions or have a fun and intelligent conversation with people. Exchange of ideas is what I like to think. All right, so we're back over here to our sensational descriptions. Wave packets sound impressive. Okay, let's take a look at what a wave packet is. In physics, a wave packet or wave train is a short burst or envelope of localized wave actions. So if I click on this, you're going to see this is what they have. You can see that moving there. This is from, I think, probably Wikipedia as well. And so this wave packet is sort of like this burst. Now, of course, if you're an etherist, you're going to say, oh, it's like, it's going through a medium. If you're a particle model like us, it's just a bunch of particles coming to in waves. Particles like bombers coming at you with spaces between groups of particles, which I think is a really good model. Actually, my father, it's one of his model he came up with. But again, wave packets, it sounds impressive. It's got the wave, the packet idea. It's modern sounding. So experimentalist reality. Experimentalists are normally less fans of theoretical physicists. I know this for a fact because in my movie Einstein Wrong, I interview a particle physicist from Stanford Linear Accelerator. He's in my film and says things like, oh, we don't see mass increase in particle accelerators, which of course throws Einstein right out the window. But that's a different story. But before we did the interview on camera, I always pre-interview. I'm sorry for those who've heard this story, but no problem. I will tell those people who haven't heard it. Basically, before all of my interviews for documentaries, I usually pre-interview people, get to know them a little bit, get them to feel comfortable with me. Because what I do is I usually ask them questions behind the camera while I'm filming, and then I film their answers or their discussion. I actually a lot of times direct some of the conversation. Sometimes it flows fine, other times I direct. So I try to get to know them. And the first thing that came out of my mouth was, so what's it like to be an theoretical physicist? And he got absolutely upset with me. I remember very clearly, he says, don't ever accuse me of being a theoretical physicist. I am an experimental physicist. There's nothing theoretical about physics. It's all real stuff. So no, I am not a theoretical physicist. I'm an experimentalist. So they are not fans of the theoretical side. So these guys doing this experiment, of course, aren't real fans of it, but they are fans of it if they can use their terminology to get noticed. So do experimentalists truly believe in Einstein's space-time? I don't think so. If I probably not. I really believe that these guys who use the term space-time will probably say, oh yeah, well, we used it, but we don't believe in it necessarily. We just used it because it involves space and it involves time. So we just put together space-time. We know people have heard of that, and maybe they'll read it. They may be just very honest about what they did. And of course, the title is a blatant attempt to bring attention to a truly interesting, truly interesting stuff. These slides, I'll admit, they're not actually done. I didn't have time to finish them, so you're going to see things in the middle here because I was actually making them for what I was maybe thinking of making my videos a little bit faster by making slides and talking to them. But a lot of my problem is I think faster than my mouth, or my mouth is slow compared to my brain. I'm not saying like I'm a super fast thinker, but I have a tendency to, as I even speak, my mind to drift. It's really great for research because it allows me to think of things maybe other people haven't, but it also creates, in my opinion, a person who's not good at being able to concentrate on what I say. I am getting better at it, so you don't hear my ums and uhs. I try to really say things in clear sentences and not speak in fragments, but a lot of times you'll hear me start on something when I get excited and not finish the sentence, jump to another. So that's why I usually script things out. So trying that. All right. The physical reality authors are manipulating the time interval and space between laser pulses. And when you read that, you could take out half of that text that was all that space-time and wave packet mumbo jumbo, wave planes. I think it was planes, those kinds of things. And you get to these real things. That's the physical reality. Depending on the timing and spacing, light seems to travel faster through mediums. What I'm doing here now is trying to just throw out all that garbage, all that marketing mumbo jumbo, and say, all right, what are they really doing? Use the words correctly. Throw out space-time wave packets. And so this is my purpose. So, these are easy and answered questions. What is light? What are photons? What's waves in a medium? How does the model of light interact with atomic structure? How does light work? They don't have a physical model for anything. That's one of the problems when they're talking about all these things. But I'm going to get back to that. This is a little bit out of sequence. I apologize. Again, I threw this together. Renaming it correctly. The original words they use, space-time wave packets. This is what I would say is the real title of this and what they should have used. Controlled laser pulses. That is what they are doing. That's the English. If I were to write this and stand up in front of a class and say, oh, they're space-time wave packets, the audience is going to look at me like, oh, crap, what's all that crap again? What is that? I have no idea. Or if I can say controlled laser pulses, everyone gets it. But the top one gets people interested. Why? Because we've abused language so long. We use words that are not physical. We make space-time. We take space, which is nothing. We take time, which is movement. We put them together and we call it a thing. That's just absurd. It's wrong. It's the wrong use of language. It's wrong. It's not a case that, oh, but Dave, that's your opinion. No, it's wrong. It's wrong. disingenuous. That word is disingenuous to what those words are supposed to mean. Now, I can call anything I want. I can make that my last name. I can call myself David Spacetime. Yeah, it's a word. I can make a whole novel of a world with Harry Potter, and I can call Spacetime, and I can do what I want. But when we're talking about real physics, and we're talking about the way the real universe works, these are the problems we have. This is why the entire 2 hours today, and I spent the first hour, all we're talking about is the misuse of scientific language. That's what we do. We confuse the heck out of people. People get all confused, and you know what's worse is that people get so stuck to it that the people who use it, who go to college, who get degrees in physics and in astronomy, and who get master's degrees and PhDs, who go on to be professors and teach their students, they live in an unrealistic, unphysical, and illogical world based upon words that mean garbage, that they do not think about the words. And when an average person looks at space and they go space and time, if you ask the person what space is, they go, oh yeah, that's the nothing where nothing is. That's where something can be, but that means there's nothing there, and then there's something over there. And then you get the dissidents and the philosophers who said space is never empty. Yes, we know that, but we have to actually have some words for these things that we made, that the universe are. That's why we have these words. So the authors are manipulating the timing and spacing, not space time. So I think that's very important. Now, again, one of the other big problems is that our vocabulary is used for more sensational and publicity than scientific truth. Those are the conclusions. Words are thrown about without revealing to the public that we have no physical model for light, gravity, magnetism, electricity, or electric fields. We don't. Maybe you subscribe to some kind of model that you have, and that's fine, but mainstream science does not. Our words are confusing and even lose their meaning to any physical reality in physics. That's true. The public are tired of it. The public is tired of it. Again, sorry about that. So we need new physical models that can tell us what this stuff is. So, alrighty. I'm going to get back to, I've actually got some more about this, but I want to take some time. I know there's been discussion. I want to go look through here and make some comments about it. Let's see here. They are mixing math concepts, it seems, with physical concepts. Yep, absolutely. If a clock measures time, would it not have time as a property? Yeah, you can make properties of things. You can make arbitrary properties or properties that are useful. Absolutely. All of our math, force is not a real thing, but force is extremely useful in our calculations. Time is based on the orbit of the Earth and its spin. Well, that's we do have to have some type of, what a second is. So we have that for sure. They are not interchangeable. Not sure what that means. It says they are tinkering with energy, nothing more, and there are many types of energy. Well, energy is not real. There is mass and it moves. Basically, that's most of the modern models will say that's what exists. There's mass and it's moving all the time. The idea of energy is a concept that's not real. Put it in my hand right here. And if you put mass in my hand, it's not energy, it's just mass. So those of us who have been in the dissonant world for quite a while, this has become a very well accepted idea that energy in fact is a concept. What did Tesla say? Everything is vibration and frequency. Again, if you can tell me what Tesla's model for light and gravity and magnetism and all that stuff is, the physical reality of that, I will have no problem. But until you do, we're still just using words. Let's see. There should be a dynamic universe. There's time for your fossil. I don't know what that means. Well said. Anomalous behavior, just not assumed by expert. Very good. Yep, I agree. You got that point that it was making there. What's it say? The language used needs to be put through a grammar matrix so there's no ambiguities in what is being. Yeah, in some sense. And I think what's happening today, those of us who are outside the mainstream, been working on this and realize that we are just abusive with scientific language, are trying to do exactly that. We're trying to, just like in this talk, in this paper, in this article, it should be the manipulation of laser pulses. That's the real thing. It's not space-time wave packets. Yeah, that's not good. Everything is energy. Again, energy is a concept. Matter is energy. So again, so it comes down to what do we have? The physicality of the world. Let me get out of this and go to this one slide that I have. All right, we'll get that. I'm not quite done. I do have some more slides that are, I think will kind of make a conclusion here. You know, these are the unanswered questions. So we talk about energy. We talk that this is energy. Matter is a slow vibration. Well, answer me these questions, 3, and the other side of the bridge you'll see. Of course, those people who know Monty Python and the Holy Grail, one of the great films of all time. These are the questions. And, you know, we can talk and use words all day long. Fields, electric fields, magnetic fields, until you have something then. Let's see. Does desperate clickbait marketing mumbo jumbo to promote their junk? Says the guy, David, who named his book Principia. No. Absolutely not true. Principia Mathematica. Next time you can try to at least spell it right. Principia Mathematica 2 was not named by us. It was named by somebody who knows the theory. They finally convinced us that that was true, that we were adding to the Principia by Newton. And it isn't marketing. In fact, we were told that's not a good title for marketing, that Universe Hack is a better model. So 16, I don't know if you're still here, probably not. A lot of trolls, people who are doing this, who are not really interested. This whole, when people come at me with the argument, oh, you're doing the same as what you're talking about, that's a cop-out. That's a, how do you say, it's a lazy person's way to just get at people. It doesn't get to me because those people aren't interesting to me anyways. They're talking. So the idea that we're talking about Principia Mathematica, it is not a marketing. Principia Mathematica would be maybe marketing to those people who even know what Principia Mathematica is, which are very few people, and very few people read Latin in the first place, which it is. And it's a pretty confusing book if you've really read it. It was never win any prizes, but of course the information in it was revolutionary, and that's all that matters. But so the whole idea of mumbo jumbo to promote their junk, sorry, very, how do you say, sophomoric comment. It's too bad. It's a lost opportunity for a person to actually learn something or say something interesting. Let's see, time cycles for day of Earth or orbit year, those are gravity motion factor of time cycles. Could be. Sure. What types of mediums does light travel faster through when going through? I haven't ever heard of that. Yeah, well, that's actually super great question, Jerry, if you're still here. The question, that was a question I had. I have to get into what this is about, because the truth of the matter is this is a very interesting experiment. It truly is. They just blew it by, messing around and trying to market it. They actually, if you throw that garbage away, it's very interesting. And I'm not sure they mean faster than light. I think they mean faster than it's expected, because light travels slower than sea and even air as it does in a vacuum. I think it's very little change, but there is a change. So, interesting question. Very, very astute, Jerry. Good question. Agreed. Spacetime is used because it's confusing, but sounds cool and futuristic. Absolutely. You and I are in agreement, and I think that's really the fact. I don't think that's something that's an opinion. I think that's a fact. Oh, here we go. Disingenuous, desperate, describe your book. We'll have to see if the person probably is already gone. Maybe not. Let's see. Where is this? My goodness. Oh, wow. There's been a lot of comments. I'm pretty far behind. Yeah, it looks like I have a troll. 16. Just holding up a mirror to David. That's no big deal. Judge at least was judged. Wise words for David. No, first of all, they're not wise words. So sorry about that. Yeah, this sophomoric person who's. It's too bad. It's really sad to see people wasting their time on not actually learning anything. I mean, if they were a good debater, then I could act. There's actually some good debates against what even our model. If you were a good debater, you could really go after it, and we can have a really good discussion. But sophomoric stuff. Let's see. Everyone is entitled to their own opinion in front of you. You need to let that happen. Da 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 da. I propose Dave make Shockwave a chat moderator. Yeah, that would be good. Actually, I can put them out of it. Good. Yeah, it's pretty tame here. People should be able to chill themselves. That's right. Usually they do. I'm reading stuff that I'm not even putting up there. I'm sorry about that. Shockwave should hear Professor Dave. Whoever is it, the chief scientist Sapphire demolishes Sapphire as a piece of junk. I don't know who that is. First of all, Sapphire is not a piece of junk. It is a pretty amazing experiment because it's a real thing doing real science with real physicality, and they actually make some very large atomic structure, I believe, and that's quite amazing. The videos about scientists and Sapphire for years because it's just forget him. The videos about a scientist Sapphire didn't help. He was a scientist. Sorry, I should just kind of move on from here. Here's a person that I do know is pretty good. Hi there. I like to say energy is the potential to transmit forces. It is interesting. Nicht von, I don't know how to pronounce that, Bedentung. Yeah, that's an interesting concept. I mean, if you really try to look at what energy is, I think it's a potential for movement and transmit forces. Yes, absolutely. I think that's a really good definition. Transfer of work, of forces, like you have a gasoline, it's sitting in your tank. Its ability to transform itself into movement of your car and forces. I think that's a very good definition. Let's see. I'm just trying to find something here that's surprise or results. Or Dave does mainstream science. Okay. We know that's kind of is that for they're a joke? No, we're not going to put that one up there. I'm just looking through this. I apologize. Reading them, he is sorely lacking in his reviews. It's garbage debunking. Light travels through empty space, and empty space is not a medium. That's very interesting too. I thought this is a comment I think worth putting up here. Light travels through empty space, and an empty space is not a medium. Again, if you are an etherist, then of course you will disagree with that. But for instance, our particle model, we agree with this, that light travels through empty space, and Again, it depends on your model. Yes, Karen Lynch, don't expend time on the troll. Yes, I apologize for that. The problem is as I'm reading them live, and when you watch this, and or if you're not saying anything and you're waiting me to scroll, and I'm not saying things, so then that's what it is. Okay, so I did get through the comments, and again, if you're interested in coming on and talking with me, it's available. Go to thegreenroom.dissidentscience.com. If you're not, don't worry. I know people may be intimidated. I will say this. I don't care what your views are. If you think everything I'm saying is wrong, if you're polite and want to discuss it, I am very polite with people. I'm the first to say that even our model, it's wrong. Our model's wrong. It may be just less wrong than what's out there. So every model's wrong. It's just we try to make it less wrong than the one before. Alrighty, so I'll leave that up. Let's see, comments. There's some more comments. My name is English, not significant. Okay, all right. All right, so let me go to, I'm not going to show you this. I'm going to get to some slides that I didn't get to. Here we go. This is an interesting slide. So we talked about, of course, the conclusions. So I'll go there and then get to my last two slides here. And here we go. Our conclusion, of course, we talked about, which is the vocabulary is used for sensational. That is what people usually try to use vocabulary for, sensational things rather than scientific truth. Words are thrown about without revealing, of course, what things really are. Our words are confusing, eventually lose meaning to any physical reality. Of course, lose public, they're tired of it, and we need new physical models. I just wanted to remind us, sort of refresh us where we were, and I'm going to the next one here, which is therefore we need new physical models that tell us what light, gravity, magnetism, electricity, and electric fields are before we can claim they understand anything, including our words. And one of the things here is one of the things here is I decided to put some of the current theories, which I think are trying to do a decent job at this. I'm not here to say I believe or don't believe any of these. Excuse me, and but I'm here to say to you, these four are ones that are being worked on quite actively right now. Infinite universe theory. I think I got that wrong. Again, I threw this together without proofreading, and I apologize, Mr. Glenn Borkert, Dr. Glenn Borkert. Apology there. He is a doctor, PhD in geology. Infinity universe theory. He's written a book on it. It's more philosophical than it is physical, although the physicality that it describes in it, the infinity part of the universe, I totally subscribe to that. Again, I think he's absolutely right. I think it's mind-boggling and very, important. And so I recommend everybody read that regardless. He is an etherist, for those who don't know. You can read a little bit more about that theory also in the universal cycle theory. Just go to Glenn Borkert on Amazon. He is one of the great scientists of our time, one of the greatest living scientists ever, in my opinion, because of his work with infinity. Energy wave theory, which is Jeff Yee, which you're going to hear. He's going to be here next week talking about it. I love his theory because it's very thorough. He's very good at describing it. He's not only has his theory, but he really tries to explain it in ways that people understand it. He generates, I think there's 19 to 24 free constants out there that in the standard model, which he has reduced down to 4. I think the whole idea of models is to make a simpler model. And he has a very interesting proposal of $15,000, which he'll be giving to people to help him model his theory in a physical modeling program called Blender, which is an open source. Just look up Blender. It's an open source program anybody can download onto the computer. I'm not sure what operating systems it works on. It may work both on a Mac and a PC, maybe even Linux. I'm not sure. Don't quote me on any of that. I do know Blender. People use it as a way to do physics using software, and he has actually a whole video on that. But stay tuned for next week. He has already agreed to be here. It'll be 6 p.m. Eastern Time, 9 p.m. here on the West Coast, and way too late in Europe. Again, I'm looking to try to get that in a time frame that's better. But again, we are recording this, so you can always, if you do miss this and it's too late for you, you can always go ahead and watch the recording later on. Tonight we're going live to Dissident YouTube channel. We're live. We're also live to the CNPS, with the Chappelle Natural Philosophy Society's YouTube channel, which has over 700 subscribers. I welcome everybody from them, and of course my subscribers from Dissident Science, over the 3,000 subscribers worldwide. I'm also streaming to Facebook, which I know some of the people actually are on. Some of my friends who wonder what the heck I do and the science stuff, they go, why would 3,000 people care about what you're talking about in science, Dave? But I appreciate it. So I've got friends, family, and my dissident science families from my channel, and also the John Chappelle Natural Philosophy Society. So thank you very much for all of you joining in. Again, greenroom.dissidentscience.com. You can come on live with me. Or maybe I should take my physics hat off here, my physics please hat off, because maybe that's scaring people away. I'm going to. I actually have a bullhorn and a light and actually a badge. It's really funny. I was making some more comedic things, and I have all those things. So pretty funny. Just for some levity here. There you go. I'm the physics police. Use the wrong words, I will let you know. I will not let you get away with mumbo jumbo. Another ether theory is by Yonel Denou and Laurie Gardy. She actually worked a little bit with Jeff Yee, and so they are now working together. Yonel Denou is also will go down in history, in my opinion, because we adopted his. Where is it? We adopted his model for magnetism, which is basically particles going in circles. And magnetism is, in our opinion, just that. He says it's ether that's going around. We just say it's particles. Doesn't matter. Ether are particles, and our particles are particles. The only difference is waves in ether are like waves, and the ether particles stay in one place and just sort of bash each other, whereas in our models, light waves travel. So that's really the only difference. But he is an etherist, and he and Laurie Gardy are actually working on what they are considering to be a thorough model of the universe. They're using a lot of things, and they're actually talking about the same things we're talking about now, which is light and magnetism, electricity, and they're now working on electricity. They've introduced a new what do you call element? I guess they call it a new element in the periodic table, which they claim, they try to give some reasoning for that existing, and they call it electrogen, like electrogen, I think they call that, and that's how they say electricity goes in a wire, because of course if you're an etherist and light is a wave and you think that electricity is a wave as well, how do you keep the wave going in wire? Well, the way they say that is, of course, they have a diagram, and you can go see that. So just look up Laurie Gardy, and she has a YouTube channel. She's past me. She's got more than 3,000 subscribers. What she talks about is a little bit more easygoing. I'm a little bit harsher in general, and I think it's one of the reasons I don't have as many people, because you got to be a little bit more, how do you say, thicker skin to be on my channel, to watch my channel. So let's take a look at that. I'm sorry, I'm not even showing that. I'm talking about the slide here. I am so sorry. I see the slide on my screen. I don't realize that I'm transmitting. It's no different. It's the same slide, folks. So we're talking about the energy wave theory with Jeff Yee. He'll be here next week, so I'm not going to talk a whole lot back. Come back next week, and we'll be talking with him live. You'll be able to even ask him questions. And of course, we have an ether theory. Of course, I was talking about with UNL Danu and Laurie Gardy. And there is, of course, the particle model by myself, D. Hilster and D. Hilster, which we are finishing up our book, which will be coming out. Got our t-shirts for it, and our website, and you can, of course, read about that. And you can go to this sensational marketing, trying to make it bigger than they are, Principia Mathematical 2, which, of course, is not a marketing. This is not a title or a website that people are even going to remember. So this whole argument that that's a whatever, but I've put Mr. 16 in timeout, so it's not worth the effort. He'll come back and make that case. So let's see here. I've got another vocabulary abuse. It's about time dilation. Do you agree? Do you agree that clocks can be influenced through gravity and movement? If so, it's not time that dilates. Absolutely. I can't remember. You gave me your name, Benjamin. I'm sorry. See if I can go back and find it. But you gave me your real name, and I apologize. I see these things, and I don't remember. But anyways, Nicht. I'll just call you Nicht, which is night, I think, in German. I've got another. Yeah, here saying that. In fact, this is called, we in the dissonant world, this will be, I think, an interesting answer for you. What we call it is clock retardation. What clock retardation means is the slowing down physically of clocks. When you put an atomic clock on a satellite and put it in the orbit for GPS, the time is not slowing down because of gravity. Gravity doesn't slow time down. What happens is everything, including atoms, look, mass is made out of atoms. Gravity acts upon atomic structure, specifically the nucleons is really what they're really acting upon. And if they're acting upon nucleons, gravity affects everything, including atomic clocks. It affects atoms. So if it affects atoms, it's going to affect even atomic clocks. Time doesn't slow down. Time isn't something that speeds up or slows down. Time is something we put some type of we put some measurement that we have as a standard. It doesn't slow down, speed up. Things move in the universe, and that movement, and when you have a standard for that, you can measure it. So yes, what we call that in dissonant world for probably about 20 years, I've heard that we use the word clock retardation. So yes, absolutely. Great question. Great question. I've also heard the universe is beyond infinite, since it would still entail some capacity of measurement. The universe is undefinable since the variables are endless. Well, this is an interesting comment for sure. What I would say to all this is that infinity actually has different sizes, but infinity is an uncountable thing, but there are mathematically, and at least that people do talk about, is there are different sizes in infinities, but you can't count them. They're an infinite number, but that is not a number in itself. So it's a concept that's a little tough to understand, but that's the answer to that. The universe is undefinable since the variables are endless. I would say it in a different way. I think we can come up with a model for the universe, but for us to model everything is really impossible. The universe is infinite all the way up and down. So what we can do is try to find its principles. Our book tries to define these 4 principles to describe the things that we haven't described before. right? Light, gravity, electricity, magnetism. And we think those things happen at all levels of the universe. So if you have galaxies, and galaxies are in motion, in random motions, and there's no organization to that movement, they're not all flowing in one direction, then that would itself cause a gravitational field of a huge thing that's gigantic, that's unimaginable maybe to us, but again, so we can come with principles that can be applied to all levels, and Newtonian principles we believe are applied at all levels of the universe. So the things that are happening at the our level are the same principles. All these principles that, for instance, we have can apply at all levels. In fact, all these principles will help us describe a subatomic level as well as the level at, and it's not the same particle. It's different levels, different particles. So yeah, I mean, that's just, again, our model, right or wrong. All right. Plasma can affect clocks. Everything can affect clocks. If plasma is real and plasma has mass, and plasma is, let's say, the free flow of electrons, whatever it is, yes, they have mass and they do affect. Says, Nick, don't feel bad. One of my names is Elwood. That's not bad. Let's see. What is your critique of quantum mechanics? Good question. Quantum mechanics basically is the dealing of the world, the subatomic world. We have the world we live in here, which is mostly, they say, is gravitic and also electric. Electric universe says there's a lot more electric parts of it than we think. But then when you get down to the subatomic world, then you get into the power of quantum mechanics, and this is where it goes wrong. What goes wrong with quantum mechanics is that they're trying to take different levels of the universe and say that things apply to all those levels. Because they do not have a model of gravity, because they don't have a model of light, because they don't know how atoms really work, they don't know how charges in atoms work, or what charge represents, they have no explanations for that. Because of all that, they're all mixed up, and that's why they're trying to include, they're saying quantum gravity. Well, if you look at our model, this is just one model, the answer becomes the gravitic random particles that make gravitational fields that causes orbits. You have the same thing happening. You have things orbiting a nucleus. We know this. This is probably one of the things that we know very much so. But the difference is, in our model, there is a gravitational field for the quantum level. In fact, its equation looks identical to the gravitational field at our level. The only difference is the particle that we call gravity right here that makes my mouse fall into my hand. We call it the G1, or the gravity 1, this level 1 gravity. What happens in our model, we say that the G1 particle, which goes around the nucleus, that's an orbit. And the only way you cause orbits is using the particle classification. It's going to be gravity, and that gravity is caused by G2, a tinier particle. That's a bunch of small particles, a level down, way smaller, way faster. It causes them. That's why the Coulomb's law equation almost looks identical to the gravitational field. And the problem with quantum mechanics is they are trying, without a model, to say, oh, I'm just going to take gravity, have no idea what it is, and try to apply it and meld special relativity at the quantum level. They don't have a model for anything. Our model solves that problem very easily, very simply. It just says, yeah, it's gravitational. But there are other particles. They're smaller and tinier particles. Just like you're looking at me, you're looking at this microphone, you're looking at the keyboard, you're looking at the screen you're looking at. It's made out of smaller particles. They're not the same. I'm not an atom. I am not an atom. I'm made up of atoms. I'm made up of cells. Those cells are made up of atoms. Well, the same thing happens in the quantum world, in our model. And the only reason I'm saying that is that's the only way we're going to answer it. Pick a model. Pick an ether model. Pick Jeff Yee's model. Jeff Yee's model is doing the same, well, trying to do the same thing. I think Not as successfully at that, I think, at that question, but he is successfully trying to answer those questions. He doesn't have infinity the way we do. But that's the problem with quantum mechanics. They don't have a physicality for anything. And because of that, they're trying to mix. They say, oh, I'm going to take this one up here and then try to apply it down here. I don't even know what to say. I mean, so quantum mechanics, it sounds really, really intriguing. It's another word, quantum mechanics, quantum mechanic world. And I got to get to my last slide here, which is one of my favorite sayings that I came up with, my own meme. There it is. The universe isn't complicated and paradoxical as our theories are, and this must change. So there I'm sitting in my old house, which I do miss, my library there. But that's the truth, folks. Our problem is we have to come up, and we're in model revolution. If you haven't seen I've done a really good video. Why do we have so many models today? That comes from the Kuhnian cycle. In the Kuhnian cycle, you start out with regular science. You then go into problems, flaws that start happening. So you have model drift, and then you have model revolution. Then you have a new model that gets back to normal science. So one of these models, this model, Jeff Yee's model, Glenn Borchert's model, Laurie Gardy and Yonel Donou's model, maybe one of those models will be the model people will gravitate to. I get it. And, then if that's the case, then we will get to the point where, we have a simpler model that describes things. And that's the purpose and why people are doing it. So quantum mechanics suffers from people not having models for these things and applying them at levels that are different. Our model tells you exactly why they're failing. They're trying to apply G1 level gravity, that is things that keep things in orbit, at a level where the things themselves that keep things in orbit, you can't use that to make themselves orbit. You can't do that. You can't do that. It's got to be something smaller that does that. Just like I said, you can't have me with all this complexity without having smaller parts that make these things up so that here I am. So I hope that answers a question, hopefully. What do you think of geometric unity or Wolfram's hypergraphic model? I'm not really that familiar with that. I'd have to look that up. I'm not liking the idea of hypergraphic model. It sounds mathematical. I'm tired of math. I've got a degree in math, folks. I love math. Math is a wonderful thing, even though the real numbers system's got a lot of problems. Square root of -1, for instance. The physics does not have negative numbers, and somehow we use them. Try to find anything negative in the universe. There's nothing negative in the universe. It's some idea where we put a 0 and then go the other way and then use the same numbers when we had to put a sign in front. That's so stupid. If you look at all physical processes, you can do all the mathematics without ever getting into the negative world. It's not that you go from, I'm at 5, now I'm going to go -3. No, there's less. Instead of 5, now you have 3. Things moved or something. But so I don't know. I apologize. I have to look that up, and I don't know more about that. John Custer, everything down is energy, not particles, but waves or different types of energy. Again, waves in what? And energy isn't real. And I'll tell you, you can talk these talks, you can use the language, you can use this language all you want. It's a free world. Well, what's going to happen are the people who are making real physical models that don't need the word energy, that don't need energy, that's just moving mass, moving forces, that don't need charge, that can explain what people call electrical fields, but they give a physicality, they're going to win. The person on the street's going to go for that. They're not going to go for, everything's like waves and it's a kind of energy. They're going to stop saying that. If you're, I don't know, smoking something and you're relaxing, you want to talk that way, and it's like, ooh, hi, hey, cool. To each their own. But let's see. Wow. Where am I? Let's see, shockwave. I'm trying to get back to where I was. Oh my gosh, there's so many more things people are lots of stuff. Kudos, Dave. Much better than Franklin's used science chat. Oh, Harry Ricker? Oh well. Well, Harry, I do want to say that it's not easy to do the Saturday mornings. I really couldn't do that for a long time. This is a different form. I do things in a different way. So I do thank you. It's supposed to be a little different from that. But again, I do appreciate Franklin at least keeping things alive, and the people who chat the way they do. People seem to keep coming to that. So. Harry Ricker, oh, by the way, I will toot Harry's boat. What? Toot Harry's boat? What the heck was that? Let me get rid of this. I do want to show you, if you haven't read Harry Ricker is a really great author. He is a great writer. Very good. And I'm going to show you, at least on Scienceworkorg, I need to put some more of his stuff. He's got a lot of articles I've been transferring from one of our websites to this, but I'm going to show you where you can read his stuff. And here we go. See our editorial staff. So let me share this here. I'm going to share. Just give me a second here. Harry Ricker, again, I really love his writing. Very talented. So I'm going to show you this. So this is our editorial staff for Scienceworkorg. Scienceworkorg is the online science magazine for critical thinkers. I have myself there, Dr. Alexander Unsker, really enjoy this. But this is Harry Hamlin Ricker III. You should read about his story, about his writing, just his backstory. But he has some really excellent articles. I mean, if you really want to read top notch, you can go here under About and go to the Ricker articles. You can see all these here are his articles. This page has been seen 165 times, but his articles have been seen a lot more all over the years. But you can go to this. I'll put this in the banners here. I'll put this on up. But if you haven't read his stuff, definitely worth your while. So let me put this. Here you go. So you can go to Scienceworkorg/Ricker-articles, and you'll be able to read Harry's articles. Very well written. Can't say enough about them. I've always intrigued about it. Dr. Chappelle, the creator of the Dissident Science Revolution, really great article. I really enjoy numbers of these. One of my favorites is Dr. Lewis Essence, inventor of atomic clock projects, rejects Einstein's relativity theory. What happened to the principle of relativity? Great article that is. Just so many of my favorites. It's like choosing a favorite child. Special relativity is irksome. Love that. You can just see here. He talks about it very well. Some really great. He puts in some nice graphics there to sort of give you some of the visualizations. Here are some of Ricker's own papers. The discussion details some of the previous papers by Harry himself. You can see it's just a lengthy article and goes on and talks about it's just history. It's fantastic. Can't say enough about it. And his writing style is extremely interesting. The cat question, Ivor Cat actually called me a couple times in the last month or two and says, Dave, I just sort of discovered you. I like the way you think. Well, I will tell you, my favorite scientists all seem to be electrical engineers. My father is one. Ivor Cat is in electrical engineering. And Harry Ricker is also, I believe, that's one of the areas. But again, Cobwebs of Space, Discovery and Interpretation of Interstellar Deaths. And he's got more, but I plan to put them on here. I do owe you, Harry, of getting some of those across. But again, kudos to Harry Ricker. He is absolutely a wonderful writer. I hope he continues to write. If you don't believe that people are watching and looking at this website, well, I have a page you can visit called Page Views, and you can see here we average anywhere from, here's a day we're at 204 reads. We started out probably about a year ago. We've almost had 50,000 reads of these things. You can see it actually doesn't go at midnight, but this is already into the next day. For some stupid reason, I set the server time to my time zone, which is now, which is 10:45, but it doesn't get it. But again, you can see there's quite a few reads, and you can actually see, for instance, the most popular pages. The most popular one is, of course, it's really gone up there, is the Relativity Abandoned Einstein. This is our chief scientist, Cynthia, talks about that. Big Bang, problems with Big Bang. Start here. You can go down here, and here's one by Harry Ricker. You can see he's got some really popular ones as well here. So take a look at all of these. There's another one of his here. So if you haven't read them, you really must read. He's quite a writer. So sorry, Harry. It's the truth. Let me get back here to find out where I was. Sorry, I'm trying. I should not give silence. That's not good. What do you think of unitary drawing? Okay, I remember that one. So we're getting close to where I was. Kudos, Dave. I remember that. That was from Harry. Here's Harry. Says Maxwell does know what light is. Unfortunately, the use of Maxwell's equations allows confused differences of opinion. That's true. Mainstream does know what light is. Unfortunately, the Maxwell. I don't know what you mean by that, Harry. May disagree with that. I don't think they say they know. They call it a wave. They call it a particle. I don't think they have any physicality for it, but that's okay. Unfortunately, the use of Maxwell. Well, Saturday mornings, a lot of the Saturday morning talks about charged particles and movements, and do those cause magnetic fields, and how do charged particles move in magnetic fields? Well, you look at my dad, who's an electrical engineer, you look at our model, we don't have any of that because we don't have charge. Particles move because there are forces, and we have forces of why those particles move, etc. So, but yeah, people talk about it. My dad just sort of shake our heads like, we're describing electronic circuits without charge, just moving particles. So it's all right. See, charge represents the time direction of the motion. No, charge was invented as a convention invented by Benjamin Franklin. He was the first to put a plus and a minus on things, and then he just said magically they attract and repulse, never telling us what those are, and that stuck around with us for quite a while. Maybe you could sort of argue it talks about direction in electronic circuits, sorta, but even that's debatable because you get the problem of what is current versus what's electricity versus, current is the moving holes that are left behind by moving the model sucks. Electrical engineering has really great empirical equations that work very well, but our model actually gives you a physical model from that. My dad's an electrical engineer for 40 years, and we're actually describing every component without charge and telling it. It's a much simpler model for it. In fact, our model predicts certain things with like parallel resistors that we actually have data for that shows a prediction of our model, which is not predicted or even cared about really by electrical engineering, is predictable by our model telling us because we give it some physicality. It's just forces, really. If you look at, let's see, if you look at how they describe things down in the quantum, it's always shown as a pattern, not particles. Yeah, look at quarks. Quarks are circles inside of another circle. There's zero physicality to any of this. The answer you get for any in the green room doesn't work. I tried it. Okay. All right. Well, if that's the case, then I will give you an invite. How's that? So here we go. If you want to be in the green room, Harry, let me get you that. I apologize. Try that, everyone. And in fact, I should be able to go. I'm pretty much swear it could be, Harry, that what's happening is that, let me see, I can make sure I can go in there and make sure that it's right. I can check it right now while we're sitting here talking. The redirection in cPanel for Linux. Let me go to subdomains. There it is. Let me check green room and see, in fact, if it's the same. You're right, it isn't. Oh my goodness, no wonder no one can get to it. Now please try it. Green room should work. I am so sorry, folks. There we go. Those people who have been trying to get in, I didn't set the domain. You gotta set the domain forwarding in cPanel for Linux, and I didn't do that, for those who know all that stuff. So anyways, try it now. That's one way to keep people out, isn't it? I apologize, folks. I'm not going to get on my case for doing things wrong, because it happens. My goodness, got so many. Yeah, I did. So take it. You should be able to get there now with green room. Try that. I did post the. I think I did, didn't I? Yeah, I should have posted the. I'll do it again. There it is. I am so sorry, folks. And I've been going on for almost 2 hours telling everybody you can get there and no one can. Harry, David is commandeering the CMPS Science chat to flog his book. Hilarity continues. Oh man, I'm going to have to put you in timeout again. Oh well, yeah. One more time like that, I'll just block them. It's sad. It's so funny. That's not what I'm doing. I'm talking about models of the universe. I know about my model. Other people, that's fine. Tell me what your model is. Don't just use words. Oh well. I wonder who that is, 16. It's a troll. One of the people who puts... You know what's really sad about people like that? If they were to take the time to look at like our model and try to understand it, that's the difference between me and other people. I look at Jeff Yee's model and I understand a lot about what he's trying to say. I look at Laurie Gardy's model and Yonel Demu's model, and I know a lot about how that tries to work. I know a lot about the ether models people are trying to propose, because you got to learn that. You got to understand those things. People don't do that. When people come out and just say pushing and all that stuff, they don't even look at it. They don't even give you an interesting argument. I can give you 10 arguments why our model has problems, but no one ever does that. They're just, you know. Alrighty. So, anyways. Let's go back, try to get over 16. He came in. I put him on timeout, but I think I'm just going to block him. All right, so you're watching him. Goodbye, Mr. 16. It's too bad. You know, it's sad that you can't learn anything. Too bad. All right. That way I don't have to read them. It's easier. All right. Okay, let's see. Coulomb's law is what they use for satellite control. It works better than Newton's equations. Okay, sure, Coulomb's law works. The problem is we don't know what that all means. That's all. We use all the equations in electrical engineering. Tons of. My dad made a very good living in research in electrical engineering using empirical equations, things that have nothing to do with the physicality, things that have to do with things that work to be able to put things together, to construct things that do useful things. And now he's got a model, working on our model, that describe everything in physical terms. Very different from what's going on, but it describes everything. It describes not only that, he is literally in the appendix, he's taking our model and generating the same curves that you see that happen for discharge of capacitors, for diodes, for transistors. He knows all this stuff. When you have a model, you have to describe with you. I guess one of the things that boggles my mind is no matter who's making a model, myself or anybody, my father, Jeff Yee, Ginsberg, Stoyan Sarge, James Carter, all these people are making models. You got to describe the universe, what's happening. I think people think that we make models and we don't think of, oh well, it does this. Yeah, we don't do that. No, it's got to describe everything. Oh my gosh. So Coulomb's law, yeah, it's a very good empirical equation. I'm not sure about what they use in satellite control or not, but our model describes it. In fact, our equation looks very identical. It's just the difference is instead of charge, we have mass. And instead of it being the graviton particle that we call gravity in our model, it's a graviton one below. It's a smaller idea. It's just a particle moving at a faster speed. It's much smaller because we believe in infinity. Okay. But yeah. We have to describe the behavior. So the satellite being controlled has to be describable by our model, but anybody's model. Doesn't matter mine. A lot of comments about 16 here. How is Coulomb similar to Newton's law of gravitation? Newton's law of gravitation is attractor. Well, because we have a model that describes that. We don't have attraction and repulsion. Okay, here's the thing. Coulomb's law describes how two things come together. Well, we describe gravitation describes how two bodies come together. Let's say two moons, two planets, two suns, two galaxies. Well, there is a gravitational field of a smaller and different particle. It's not the same. You have to understand that there are levels to the universe, that when you get down to the nucleon level in a model that's like an infinity model, like a Borchardt model or the Hilster model, that you look at the nucleons as suns and there's a gravitational field there, but the gravitational field, the particles for our gravitational field at our level become the planets of that level, and the nucleons are the suns, and you have particles that are even below that. That's how. It's a gravatic, that's why this is our, I'm not here to tell you the way of the universe. This is our model. That's all I know. I don't know other models that describe it. So tell me another model. Tell me how that model describes it for us, other than saying there's Coulomb's law. There are no laws in the universe. The universe doesn't have, like, we're not going to go to some asteroid somewhere to say, oh, the universe was designed and here's its law. Laws are made by human beings, hoping we came up with some idea of the way things work. So, anyways, I hope that answers your question a little bit. Both are proportional to the inverse square of distance. Yeah. You want to see it? All right. I will show you again. I'm giving you an example that I know. No one else is answering this question, so as soon as they give me the answer, I'll show you their webpage. That's no problem. So let me go to this, our page for the particle model, and show you the equations and how our equation works. It's just so really simple. Let me show you. Again, here we go. Right here, there's the gravitational equation, Newton's gravitational equation. Below that, the third one right here, is Coulomb's law, which is basically Q1, Q2 over R2. We have M2 over R2, and instead of the constant here for Coulomb's law, we have the gravitational G2 constant. It's just the same. The only difference is here, this field appears is gravitons at our level, graviton 1 level, and here graviton 2. They travel way faster than the speed of light, but they make electrons orbit. That's why it looks so similar. That's one of the reasons we say our model works. It shows this relationship is the same. Why is that? Well, if you look at Principia, our little movement classification, you go here. This is what we say. This is what we talk about. A gravitic particles that are similar going in all directions cause a gravitic field. Whether or not these are galaxies, whether or not these are planets, whether or not these are gravitons, whether or not these are a graviton 2 way below that causes light to bend, that causes electrons to orbit. That's one interpretation. That's one model. Okay. Well, again, is it right? No, our model's wrong. Absolutely wrong. All models are wrong. Like I said, they can be less wrong. NASA knows that satellites act as bodies with a charge potential, not positive or negative. Charges are arbitrary, but okay. Dave, you can post the link in the chat window. Okay, I have done that. No one's joined, but I don't know if you have tried to join. Let me know. There are the links I put. Lori has a good grasp on the way to unify the theories. I think is it Lori Gardy you're talking about? Interesting, yeah, but I think it's missing quite a bit yet, in my opinion. But yeah, she's trying. I have to give her, I'll take my hats off to her, and I will support her 100%. I think I have a lot of questions for her. I think doesn't unify as much as people say, but she's trying to. She's starting to. They're trying to do that. It's got to do with the U and its theories. Yeah, it's theory. Again, I think it's theory. It's not physical models. I know how Coulomb's laws are similar. Again, our model will give you a real physical forces Newtonian reason for both and why they're similar. They're the same. They're the result of particles moving in random directions. It's again one model's idea. Apply Coulomb's constant to masses. Instead of G, there would be masses in a row. The mass made by Coulomb's law calculated with the possible. Actually, my dad has looked into this in our model for that. Other models, I'd be curious. How do etherists do it? Etherists are trying to make the entire universe into ether, so give us a answer to it. Don't know what that is. Yes, fractal woman. Yes, I was talking about that. Yeah, I mean, again, there's a lot of verbiage that people use, and right now they're trying to unify electricity and, well, Denew is unified what, and in his model, it's probably better to use this, sorry. This part of the model, which we call this part. This magnetic fields this is not us. This is not our. This is from Lionel Denis. Magnetism are just simply particles going in circles, and the reason you get repulsion and attraction is because go to Lionel Denis on YouTube. He has very beautiful experiments showing this. That when the two circles of particles meet, if they are going in the same direction, they attract. They cause attraction. If they hit each other and going in opposite directions, they call repulsion. Again, that's totally, and so they're using it. So Lionel Denis and Laurie Gardy are using that same thing because Lionel Denis came up with it. They're now trying to do magnetism, which we don't have a problem with it because we're our particles, so particles can easily be guided. Imagine if you set up suns in a row, you could guide comets through there. You shoot comets through there and they create a gravitational field. That's the same thing. It's just that we have a gravitational field. This one, a different one, same idea down below, G2 particles. So we don't have that problem, but they're now trying to unify. They are doing magnetism and ether. So they've got light and magnetism. They're now trying to do electric. Their last part is gravitic, and a lot of people who are doing ether try to insert gravitation into ether theories. And the only reason I think that's somewhat futile is because ether is only a light-based idea. It's not supposed to include gravity, in my opinion. It's like saying I'm going to make everything out of cars, whether or not that's a good idea or not. So that's one of the reasons I never subscribed to. I was never an etherist myself. But could they be right? Absolutely. Laurie Gardy and Lionel Denis could be the next great scientists of our time. You don't know. I never put anything past anybody. So I could join and say hi, but that's about it. Okay, no problem. Absolutely no problem. Yep, and hey, Kip Stolberg is here, I see. Hey, Kip. He was my MC for the premiere of my movie Einstein Wrong. In fact, he got me to do the movie in the first place, which probably got me here. Super great guy. He's a comedian, actor. I told him, Kip, you need to make a YouTube channel with your family. You can make a living off that one. Anyways, let's see. This means Coulomb's constant fades the longer the rows of masses will get straight, where it seems a Coulomb constant. Yep. Yeah, Coulomb's law has the mathematics behind it. The question is, what's the physicality behind it? There could be different physicalities. Let's see. Shockwave. The electric universe just says to add the electric force into gravity mass model that already exists, and you will have a better model of the universe. Yep, you can say that. Again, I guess the only question I would say, again, hats off to the electric universe and anybody else trying to figure it out. Anybody who is actually here trying to, think about the universe outside the mainstream. My physics hat is off to all of you. So I do not poo-poo or say anything about I'm right and you're wrong, or you're right and I'm wrong. The idea is it's a free world. But again, we are into a phase, going back to the slides that I was showing. We are in a point in the model revolution, in my opinion, where we are looking for physical models, and we are now starting to see that come to fruition. And that is, hold on, I'm going to bring this up, here we go. That is where we're at, and this is what I have here, which says we need new physical models that tells us what light, gravity, magnetism, electricity, or electric fields are before we can claim to understand anything. That's where we are. And these people I'm listing here, they are the ones that I see who are trying to do that. Lionel Denis and Laurie Gardy, yep, they are trying to do their three. Their electricity they're trying to do. They're introducing a new element. They'll think it's a little bit of contrived, but look, They could be right. There could be this element that they say exists, and that's why ether can stay within a wire. I think that is a problem for ether theories, and they're trying to address it. And they're going to try to fit gravity into it. That's great. Electric universe is it an ether theory? Is it a particle theory? I don't know. Right now, the way I look at it, they're doing a very interesting experiment. I'm not sure in reality if it's actually it's proving that the universe is electric more or not, but it's certainly coming up with really great information, great results in a real experiment with real results, and people have to pay attention to it. And I take my hat off to them for sure. Have you checked out the Mercarian evolution? No, I have not. I really haven't looked into evolution that much. It's not one of the things I really have looked at. I think you had to look in Darwinian evolution, how it applies to physics. I will say this about evolution. I think time frames wise, what we see as evolution and the shifts and how it happens, I think we don't have a whole lot of handle on that yet. I mean, when I look at the immense changes and I think a very short time, I've done some calculations on how long it would take us for progression to happen. Maybe they happen in bigger leaps and then not so, but I don't know. I think that's ample, and I think it's something that is open. Look, we should be able to question everything. We should be able to question evolution, everything. So I think it's important that we allow people to do that. If I had a student and I was in physics and they want to come to me and say, I think the Earth's flat and here's why, go for it. Go like crazy. Try to convince other people. The whole rule is, if you're going to try it, if you have an idea, you think it's right, come up with your arguments, and you have to convince people. And one of the problems people have is that people use lots of words, and the words end up meaning nothing because they just use vocabulary after vocabulary. Space, time, dark matter, energy's the big one. Oh, there's energy over here, and I think it's like the energy. It's like things are made of energy. It's a concept. If you don't believe it's a concept, look at the units. Everything has units, right? Pounds or kilos or meters or newtons. Look at energy. Energy has, 700 different units? Why? Because it's not a thing. It's a convenient thing we use to try to translate it. So we use, the problem in science is we use words in science like space-time because we think we have in science the liberty to be able to use any language in any way we want. And it's not true. All we do is get into trouble. That's what the whole idea is here. This whole talk I've been talking about is what is it that we get into trouble, and what we get into trouble is, let me put this down here, get this sharing correctly, get back to it because we're going to be probably wrapping it up here, but there we go. Just get the whole screen this time. Whoa, that's not right at all. Oh, I could go back. There we go. The words of science are terrible recklessness with scientific terminology. And that's absolutely true. Anyways, here are some more comments here. Shockwave Coulomb's law is proven to be an approximation of the Gaussian surface integrals of Maxwell's equations. Okay, John, you're going to come back with the same question. The surface integrals in Maxwell's equations can work mathematically, perhaps predict things that may be useful, but it doesn't tell us what it is. It still doesn't tell us what electric field is, doesn't tell us what we describe as charge, attraction, and repulsion. Doesn't tell us at all. None. Zero. And that's the problem. And I'm a mathematician. I like math, but we get caught up in that. We get caught up in all of these things. Alrighty. Let's maybe put up a few of the. Again, if you want to discuss, we can go to greenroom.dissidentscience.com. You can go there. I apologize. I put that up from the beginning. People probably were trying to go to it and wasn't able to get to it, and they just think I'm crazy. I've got to make sure I double check with that. Again, if you are, let's see if I have that graphic somewhere while I'm talking here. But next week we will be talking with Jeff Yee, and Jeff Yee is the author of a theory he calls the energy wave theory. You can go to energywavetheory.com, and he has a project where he is actually sponsoring $15,000 worth of work, software programming, to try to represent his model in a Newtonian world, completely Newtonian world. He and I are in 100% agreement. The universe is Newtonian at all levels. I believe there's infinite levels up and down, but they're all Newtonian, all of them, from all up. In our model, so far has been successful in using that for many things that people haven't been able to describe, like dispersion, why things get into rainbows. It'll be in our book. That diagram is very interesting. But again, he will be here. Let me see if I can come up with I've got a graphic for that, which I can bring up, which will be coming right after this. Because Facebook allows 7 days ahead, so I don't like to usually launch it ahead of time. But here we go. I got it. And I will share that graphic with you all. And let me remove this one and do another share. Whoops. There it is, but I want to unshare that and get rid of it. Stop screen sharing. Sorry about that. And get to it so we can get a clean picture of that. Here we go, nice and big. There we go, and share that so you guys can see it. So this is, let me get the branding off here. There we go. So if you want to learn more about it, you can go to energywavetheory.com. He has a project, $15,000, offered to simulate in software the creation of particles, atoms, and matter with classical physics. That is absolutely fantastic. I take my hat off to him. We will be here next week at 9 p.m. Eastern Time to talk with him. I will get the links right, greenroom.dissident.com. Please, in the future, let me know about that ahead of time. You're going to meet him. I'm going to give him time to talk about that. He has a video. You can see he's got a whole video on that already. Take a look at that. We're going to walk through it with him, but we're going to talk to a real live dissident scientist who really is going at it, really being able to describe his model. Again, I support people's work that do in fact use Newton's classical physics to describe the entire universe. I think that's the way to go. I think that's the brave way to go, and the way for us to get from fantasy and just words to real physicality. Here's John Custord saying, Dave, if the world's Newtonian, why does the action-reaction pair happen? Well, you have to have a model, and we can describe those things with Newtonian forces. That's the answer. Now, of course, people are going to say you can't do it. Well, you can. So, most important, I think that we are trying, and we're trying to get this. And this is going to answer the question that I've asked since I was a kid. What is this stuff really? You can talk about reaction. It's not Newtonian. It's not Newtonian because we don't have a model for it. It's not Newtonian because it's all it is empirical equations. Those equations have no intention, including Maxwell's equations, to give us any idea of what the physicality for any of this stuff is. So I think that's one of the reasons. So anyways, energy wave product is coming up. Any more questions before we get off the air? I'll be willing to entertain them. We've been on, oh my gosh, 2 hours and 20 minutes. People do come and go. I want to thank, again, my dissident science people. I've been seeing that many people from that coming in and out. I appreciate your subscriptions. I am coming out with my new edited versions of the videos coming out, but a lot of people enjoy this banter because I am the physics police. I am ruthless. And I also support anybody who does, in fact, open-minded and says, hey, I'm going to try anything. I don't care what your theory is, what your model is. I really think it's important that we all support open thinking and the ability. Go at it. If you think the universe is electric, go for it. The only thing I ask everybody to think about is make sure you try to, in the end, think of what it really is, because empirical equations eventually are not going to hack it. We're going to have models that really tell us what the heck a magnetic field is, what physical thing is happening there, and why is the attraction happening, and that's where we get the answers. So, alrighty, folks. Again, I want to thank everybody, and I'll go out with my stinger here, and I hope you've enjoyed this session. If you have any questions or suggestions, let me know. You can join me. Let's see, you do see one more. David, can you explain what I mean by action reaction? I'm not sure, but all I am saying that is I believe everything in the universe can be explained in Newtonian terms. I think action reaction also can be explained, whatever that is. I believe that everything can be. So no, I don't know exactly what you're saying. And of course, people are going to accuse me of using my model, but that's the one I know, and we're trying to. So ask Jeff Yee how he does it, or ask Yonel Denou and Laurie Gardy how they do it, or ask Glenn Borkert what he is doing. Let's see. What if someone has a theory and it supports Big Bang then? Well, here's what happens there. That's a good question. What happens is, as Big Bang, which today I will tell you, there are a lot of mainstream cosmologists. Let me say it again. Mainstream cosmologists who are now starting to say Big Bang never happened. So the answer to that question is if you have a theory that describes the Big Bang, and with time, astronomers, even in mainstream, said, nope, didn't happen. It's illogical, makes no sense. It's makes more sense that eternal universe, it's more of a soup, it's a cycle, whatever it is, it's not a Big Bang. Then what you do is I tell people, if you have a theory that describes something that doesn't exist, you're stuck with that. Or you have to say, well, you can describe it. So that's the answer. So yes, there are particle models that describe quarks. I don't think quarks exist. There are particle models, physical models of the universe that describe neutrinos. I don't think neutrinos exist. There are models that say gravity bends light. I do not believe that happens. G2 gravity bends light, but that's a different gravity from the gravity you knew. But again, your model can say those things. If you tie your hat, you better do your research on neutrinos. You got to find out if those things really exist before you go and say, oh, here's what neutrinos are, and then it turns out neutrinos don't exist. If your model depends on that, you've just hung your hat on something that's going to go away. That's not good. So I see lots of dissidents hanging their hats on things that they didn't take time to look at. I've taken the time to look at it. I don't look at even the electron until I think there's a real electron before I say that should be in a model. So people don't do that. What if someone can logically explain the evidence of recessional redshift of galaxy? Well, they can explain redshift. Oh, people have done that. Our model describes redshift, but it's not redshift because of movement. So you're saying recessional redshift. No, you can describe redshift without saying that it's the movement. It's just the way light works, because light doesn't go through the universe unimpeded, unobstructed forever. People have this idea in mainstream physics that if you shoot a laser out in the universe there, it'll go forever. Nope. Our model and other people's model says no, it won't. Philosophically, it won't happen. So you're saying evidence of recessional redshift. Well, that what I would say is there's evidence for redshift. It's not recessional, and so you have to be careful. That's a circular argument. The recessional comes from redshift. It's not recessional redshift. Redshift gave people the idea that comes with the idea that there things are moving. They are not attached. Redshift is not proof of recession. Recession is an explanation for redshift. Redshift can be explained much better, in my opinion, by non-recessional explanations. Again, that's what I'm saying. Alrighty, two and a half hours. Okay, do I see any more? See, David has a police baton. He can hit you over the head with it, pun intended. Yep, actually, I've got my badge here. I should have showed you. I have my badge. I actually have a bullhorn, and I have a red light. I'll have to get those out. Some people like that. I tried that actually in some of my videos, and some people were totally turned off by that. Said, I think redshift is due to electron density. Don't know. I don't think it's recessional. If you don't think it's recessional either, then I agree with you on that. But yeah, that could be it. We don't know what, but we have to get over the fact that redshift, in most people's opinion, including, boy, it was back in 1999, I went to an astronomy club on Long Island that Einstein used to go to. And all the people there, 1999, the amateur astronomers, none of them believed that redshift was an expansion. None of them. This is 99. The only people who believe that are the theoreticians, the few theoreticians that hold on to it, and the people who read it who want to, I think, appear smart. Be careful, folks. Be careful. The realities of what really people think in the mainstream science, the mainstream's this big. It's got this many people in it. The people who love science is 1 billion times bigger than mainstream. There are millions more people who are not mainstream people who don't buy a lot of this. So be very careful where you hang your hat. Okay, folks, thank you so much. Thanks to my friends. Thanks to the CNPS. And thanks to my Dissident Science subscribers. Greatly appreciated. And thank you all who participated. I'm not here to make anybody feel stupid. I'm here to give you my best answers to questions after hanging out with the best, what I consider some of the best minds outside of mainstream science. A lot of these ideas are not my own. I'm just repeating a lot of what we outside of mainstream have been talking about for decades. So take care, everybody, and we'll go out with a bang. Ciao for now, everyone.